everyone. Welcome to the second day of Tokenized Real-World Asset Bootcamp by Chainlink Labs. My name is Andre, and I'm one of the developer relations engineers here at Chainlink Labs. If you can hear me, see me, etc., please drop in a chat where you're tuning in from, and we are gonna easily start with today's lecture. So this is the second day of the bootcamp, and also the final day. So like after this day, that's it. We'll have some homework and some follow-up discussion on Discord, but that's pretty much it. The URL for the Gitbook is the same as yesterday, so cll-devrel.gitbook.io/tokenized-RWA-bootcamp-2024 right here in the chat, and I'm gonna quickly start sharing my screen while you're dropping your GMs in the chat. So yeah, I see people joining us from Lisbon, Madrid, India, Naples. So hello everyone. Oh, there's Pakistan as well. Nice. Okay, cool. So you should be able to see the exercise number 2 page. So we're gonna start from this page today. So first we're gonna have a quick recap of day 1, and after that we're gonna start with exercises for day 2. So there is little to no theory today, just pure coding and engineering. GM from Nigeria, Cameroon, Argentina, Norway, and Toronto, Canada. Hello everyone. And GM to one and only Harry Paparizou. Okay, cool. So we're gonna start first by recapping what we have done yesterday. And this is going to be these contracts we deployed yesterday are going to be our base for today's workshops, for today's exercises. Sorry. So yesterday we deployed our real estate token.sol contract, which is essentially smart contract implementing ERC 1155 standard, and in a form more like fungible tokens representing non-fungible asset, and that non-fungible asset is actually that mock real estate from Zillow's API. So we essentially tokenized mock real estate like a house using Chainlink Functions and ERC 1155 standard, and we've also deployed the issuer smart contract, which we'll use just for issuance purposes. We basically minted that one token to Alice or to your own wallet addresses. So today we are going to continue using that real estate token.sol, that tokenized real estate, and we're going to plug it into 2 different use cases. So first one is going to be real world asset lending and borrowing, our own mock version of lending and borrowing platform, minimal version of lending and borrowing platform for real world assets, specifically for our own ERC 1155 real estate using from Zillow API. And the second one will be an English auction. The great part about ERC 1155 standard is that you can represent, as I said, non-fungible asset with certain amount of fungible assets, fungible tokens, meaning that you can have like a fractionalized version of non-fungible asset. In our case, that's a fractional version of real estate. And if I go back here to the previous diagrams, we can see once again that we tokenized this house using Zillow API like mock real estate and minted 20 ERC 1155 tokens. 20 tokens to Alice address means that she or your wallet address now possess 100% of that real estate, of that tokenized real estate. But if, as we wrote over here, if Alice sends, transfers, or sells 5 of these 20 tokens to Bob, now Bob owns 5 out of 20, means like 25% of that non-tokenized, non-fungible asset, right? So that's pretty much it, what we've done yesterday. And if you missed yesterday's class, you can rewatch it if you go to Always Stay Connected page. This is the link to the official YouTube channel. Also, here it is in a chat. So you can subscribe to Chainlink's official YouTube channel, and over there you'll find the recording of day one. Also, this video is currently played live as a live stream on YouTube, but once we stop recording, it will be immediately available to watch on demand at the same YouTube channel, so you can always rewatch it at your own pace later. Now we're gonna start with exercise number 2. So these are the 2 contracts that we are gonna create today. I'm gonna start with the second one, with the English auction, because it's easier. So as I said, if Alice transfers her like 5 out of 20 those tokens, whatever, like 10 that will, then that means that Bob will own 25% or 50% if she transfers 10 tokens of that tokenized real world asset of that house. However, Alice can also sell those 25% or 50% or 75% of or whatever. And she can do it by creating a decentralized auction. And for this purpose, we're going to create a mini version of English auction smart contract. But also there is another one called Dutch auction, which is quite popular on blockchain as well. These 2 are probably the most popular ones, but of course you can just implement auction on your own. And this auction will be simple. Alice will deploy this contract. She will send the portion of her ERC-1155 tokens, like tokenized asset, like the fraction of it, and set the minimum bidding amount. Then the bidding will last for 7 days, and anyone will be able to bid with the native coin of that blockchain. So I'm gonna do it on Avalanche Fuji. So that'll be like anyone can bid in AVAX coins. If I'm on Ethereum Sepolia, that'll be in ETH. If I'm on Polygon Amoi, that'll be Pol, and etc. etc. So that means that in our smart contract we will leverage the message.value keyword, and the only constraint will be that the next bid must be higher than the previous highest one. Also, you can withdraw your bids if you're not the highest bidder, and after 7 days, anyone, or we can even send like Chainlink automation, will close the auction. So that's the broad idea. We're gonna deep dive into it more later, but that's what we're gonna build. But first of all, as exercise number 1, we're going to create this RW lending smart contract, which will leverage Chainlink price fits. And this one is much more complex, and that's intentionally because we want to show you the complex use cases that can be built using Chainlink platform, right? I see questions about English and Dutch auctions in a chat. I'll answer those later as we start explaining the exercise number 3. Don't worry about that. If you can always read about them in a Gitbook as well, but be patient. So we're going to create for exercise number 2 RWA lending smart contract. So essentially, we will lock certain amount of ERC-1155 tokens in it. So again, certain fraction of those tokens, like 25%, 50%, even 100% if Alice wants that, in order to get a loan in USDC in return. So it's stable tokens. The calculation for price, because again, we don't have proof of reserve feed for mock real estate, right? We're gonna leverage our get price details function that we developed yesterday, which essentially pings using Chainlink Functions, pings Zillow API every single day, automated by Chainlink automation. You remember time-based upkeep. And it will return list price, original list price, and tax assessed value in US dollars. We will use the following formula, this one, to calculate the valuation of that real estate, of that Alice's mock house. And we can see that W1, W2, and W3 variables we have in this formula. Those stands for weights. So weight 1, weight 2, weight 3. We'll see later, but that means that list price has like a greater weight than tax assessed value when we want to calculate the valuation. This is just, again, a simple example of what can be built, and it's just tied to this mock RWA lending platform. Valuation will be calculated in US dollars because we have list price, original list price, and tax assessed value in US dollars, and weights are just like constants essentially. The thing is that we'll talk about it, but we will need to convert US dollars to USDC because one USDC does not always equal $1. It's quite the opposite. It's in the range between 0.99 something and 1.011 something. So that's how the actual price of all of these stable coins are work. So we're gonna use Chainlink price feeds, specifically USDC in terms of USD, to convert US dollars to the actual USDC value, and that USDC value will be transferred back to Alice. Finally, because this is lending and borrowing, Alice can always repay her debt in USDC and get her ERC1155 tokens in return. However, if the value of real estate drops below the liquidation threshold, anyone can liquidate this position, and the Alice will lose all of her ERC1155 tokens, all the fractional share of an asset. She can keep the USDC though. So the same mechanism as in Aave or Maker or any popular DeFi lending and borrowing platform you're already familiar with. So that's the high overview. Now we're gonna start with the actual development. So once again, I'm gonna remind you of yesterday's class. Yesterday we deployed real estate token and issuer smart contract, but we're interested now in real estate.sl token or contract to Avalanche Fuji. The original plan was to deploy this to Ethereum Sepolia, but gas fees has been ridiculously high on Ethereum Sepolia over the last week actually. So we decided to switch to Avalanche Fuji. If you do not have enough AVAX coins or link on Avalanche Fuji or on Ethereum, whatever, you can deploy these contracts for homework and for these exercises to any testnet you want. Any testnet you find convenient for usage in terms of fees, any testnet but you have enough testnet tokens and coins, it doesn't matter. The only thing that matters is that if you go to official docs and click quick links wherever you are, there is always this button, quick links. You just need to be sure that CCIP, data feeds, functions, and automation are supported on that test network, so you can complete all the steps. And that's pretty much any standard test network are there. Arbitrum Sepolia, Avalanche Fuji, Base Sepolia, what else? Optimism Sepolia, Polygon Ammo, Ethereum Sepolia, and others. So as I said multiple times yesterday and on Discord, feel free to use any testnet you find convenient. Because this token has implemented CCIP functionality in it natively, so you can always cross-chain transfer them to different blockchains using Chainlink CCIP pretty easy. So don't worry about that. As I said, I'm going to continue working on Avalanche Fuji because I've already deployed and set up my real estate token over there. Okay, cool. So we have minted yesterday the token ID 0 to Alice with a bunch of different real estate details, from number of bedrooms to the address of real estate, etc. Then we set up time-based automation to call the update price details, this function, every single day on each 24 hours. Specifically at midnight UTC, in order to update price details of this real estate. And also for test purposes, you can call this function whenever you want from the owner address as well. But if all of these details can be found here. So this is the time-based automation we set yesterday, and we can see that the latest run was at midnight UTC, October 1st, which was today, right? And yeah, we can see that little over 0.2 links. Yeah, little over 0.02 links were actually, spent for this run. So we have plenty of link to spare. If I now call get price details, which is a view function, right? I should be able to see, instead of 000, list price, original list price, and tax assessed value of this token. And we can see these values. I'm just gonna copy them here because it's a bit easier to follow. So this is, again, list price in US dollars. This is original list price in US dollars. And this is tax assessed value, again, in US dollars. So we can see it's that these values range from 760,000 something dollars to even 7,000 dollars to 700, almost 730,000 dollars. Sorry. So this meant that initially, when the owner, when Alice posted this mock real estate for sale, they put this price, but since they haven't sold it yet, they updated the price multiple times, and the current one is this one, $10,000, almost $10,000 easier. So this is constant, which is not going to change. This is list price that owner can change, and tax assessed value is actually an external constant, so owner cannot change that. This is literally as the variable said, tax assessed value for this mock real estate. And we're going to use these three values. Our smart contract will essentially going to call the get price details function to put them inside this formula. So once again, this is a formula for valuation where W stands for weight. And we will have three different weights. That means that one of the list price has more impact to the final valuation than tax assessed value if the weight one is 0.5 or 50, and 50%, and the tax assessed value is, for example, 20% or 0.2. So this is all just pure math. And again, this is mock version or mock implementation of this lending and borrowing platform. Is extremely simply. You don't need to implement it like this. This is just an example. And also in a real world scenario, you'll probably use proof of reserve feed for that asset instead of pinging functions request, pinging functions, sending functions request using Chainlink automation every single day. But we needed to do that in order to make this mock version work, and also it was a nice way to showcase you what's possible with Chainlink platform. Okay, let's now create a new folder called use cases in root, and a new file called rwalending.sl. So again, read the Gitboot carefully, listen to me carefully, create a new folder called use cases, or however you want to call it, doesn't matter. And inside that folder in the root, create rwalending.sl smart contract. This is important because we are importing real estate token like this. So if you don't want to have, again, issues with compilation, you should just carefully follow the instructions, right? If you have issues, again, this is medium to advanced bootcamp, so you should probably be able to solve it. This is Solidity 101 essentially, so nothing hard there. Again, my compiler is set to 0.8.24 version of Solidity compiler. Optimizer is enabled, turned to 200 runs, and for EVM version, I've set Paris because of the cross-chain stuff and compatibility between different EVM versions of different test networks. So, okay, I'm gonna collapse all this stuff, and I'm gonna create a new folder called use cases, and inside that folder, RWA lending.sol. I'm gonna paste this code and I'm gonna quickly walk you through it, function by function, actually. So let's see what first we're gonna cover. Receiver. Okay, cool. So first of all, you will see that this smart contract imports IRC 1155 receiver interface. And this is important because ERC 1155 token can be sent to externally owned accounts natively, but the same as for ERC 721, like for NFTs, the same goes with your ERC 1155. If you want to send your NFT or ERC 1155 token to a smart contract must implement this interface, must inherit this interface, and specifically implement the on ERC 1155 received, which is this function, right? So same as NFTs, right? If you want to send NFT to a smart contract, you need to implement on ERC 721 received. Here for ERC 1155, we implement on ERC 1155 received. All of these details you can find in the official EAP. That's part of the standard. It's pretty standard stuff, and that's how we roll. So that's why our smart contract needs to implement that. You'll probably see, not just for ERC 1155, but also for NFTs, that in a lot of implementation, that on ERC 721 or 1155 received function is empty. You will see just something like this. So just returning selector and nothing more than that. This is wrong. For production ready apps, you need to implement at least two security, let's say best practices or security measurements. The first one, you want to always validate that message.sender is the address of real estate token.sol smart contract. So that's the first one, and you want to receive only tokens from that address to avoid any potential issues. You obviously need to return the selector, but you also want to check this thing. And also you want to put non-reentrant modifier on top of this function, because these tokens have hooks usually in their implementation, post-transaction hooks, sometimes pre-transaction hooks, and hooks are dangerous because can be used for performing various different types of reentrancy attacks. So this is why we have this on ERC 1155 received function. Similarly, there is also on ERC 1155 batch received function, just following the ERC 1155 standard. And of course, there is this supports interface view function following the ERC 165 standard, which is one of the oldest standards, pretty common. If you are not sure what this thing does, you can always just refer to the original EAP. It's extremely straightforward. So that'll be it for this part. If you have any questions about this smart contract, about its implementation, or any details, feel free to drop them in a chat. I'll try to explain them in more detail. But yeah, like the purpose of this exercise is to understand these more advanced practices and design decisions for this smart contract, because the exercise itself is going to be extremely straightforward. We're just going to deploy this smart contract, which is, nothing hard. Okay. That's that for ERC 1155 receiver. The second one is initial and liquidation thresholds. And for simplicity reasons, and in this mock example, we hard-coded these values. In production, we will see that there will be like Multisig special roles that can update these values. Depends on governance voting or market conditions or whatever. But we, for simplicity reasons, hard-coded them to 60 or 75%. What that means, and let's see the actual code. So we have two variables, LTV initial threshold and LTV liquidation threshold, just hard-coded as immutable variables to 60 and 75. That means that if L is fractional real estate worth, for simplicity reasons, $100, she will get a maximum of 6, and let's say that 1 USDC equals $1 just for this exercise. That means that she will get 60 USDC in return. So she borrows real estate worth of $100, $100, and she gets 60 USDC in return as a loan. Once she repaid those 60 USDC, she will get her real estate back. She can do with that 60 USDC whatever she wants. But that's how the DeFi loans work. However, if price of her real estate drops below $75, like 75% of $100 of the original price, anyone will be able to liquidate its position, and she will lose all of her ERC1155 tokens. She can keep USDC though. So that's the liquidation event. If you have any questions about initial and liquidation thresholds, feel free to drop them in the chat. If you're familiar with how Maker works, for example, or Aave, or I think even Compound has those values, you should be able to understand this pretty easily. And obviously, for simplicity reasons, so we can have like a contract which is a little over 200 lines long. We just hard coded this to 60 or 75%. We will see the usage of these two variables in both borrow and liquidate function. So borrow, you can for initial threshold, because if she borrows for real estate of $100, she need to get 60 in return. So that's why here and for liquidation threshold, that's in liquidate function, obviously. Once we calculate it, it's going to be like this. Okay, cool. The third part. The third part is the borrow function. Let's first analyze the borrow function implementation. So we can see here that first of all, there is a check if there is an active loan for that token ID. And if there is, if you already borrowed some USDC for that token ID, you cannot borrow anymore. Again, this is for simplicity reasons, because it's much easier for you to understand some concepts. Then we calculate the normalized valuation, and we will go into that. We'll deep dive into that soon, but essentially, we will calculate the actual valuation using that math formula, and then we will ping Chainlink price fits to convert US dollars to USDC, and finally we will get the normalized valuation amount back in return. So bear with me with that. But this line is going to be extremely important later. So line 83, if you want, if you want to memorize that. If normal valuation is 0, we're going to revert. And then we're going to calculate the loan amount. So as I said, if the value of an asset is worth $100, but you can get 60% of that, well, I mean $60 in return. Over here, we're essentially calculating this loan amount, which should be like $60. And first we have here the slippage tolerance access, like the first slippage parameter. So for slippage protection, we need to provide minimum loan amount and max liquidation thresholds values to protect against slippage. So slippage is unlikely here in this scenario, but in general in DeFi space, it's pretty common thing. So essentially, you will create your, let's say you were using some DEX like Uniswap, and you want to swap token A for token B, and you create your transaction, and it's in the mempool. The MEV searchers will try to extract value from it, either by front-running you or creating a sandwich attack, right? And because of that, you want to put a slippage protection in place. Essentially, this means that, okay, I'm calling the borrow function, I'm loaning this amount of ERC1155 tokens, let's say 25% that I wanted to send to Bob, but I want to calculate upfront, like completely off-chain, the amount of USDC I expect. So let's say that, again, my fractionalized asset worth $100. I expect maximum of 60 USDC in return if $1 equals 1 USDC, but that's not the case always. But in this hypothetical example, but also, what if someone can manipulate the price of my real estate or the price of USDC? Highly unlikely in this scenario, but with ERC20 tokens and with DEXs, it's more likely, and actually it's pretty common. So that means that, okay, I might get up to $60 or 59 or 58 or whatever, but what's the minimum amount of USDC I'm willing to get in return for this borrow? And you can put as minimum loan amount 50, for example. You are comfortable with, or 55 with that range. So if anyone tries to sandwich attack you, you have a slippage protection in place. The same thing goes for liquidation thresholds. So for liquidation threshold, you want to put the maximum amount of liquidation threshold, which again here will be 75%, but the actual maximum amount, because it's gonna calculate the price of your real estate dynamically, right? And if liquidation threshold amount is amount is too high, that means that, let's say that it's somehow someone manipulate your price, and liquidation threshold amount is now set to 90%. It's calculated to $90. Sorry, $90. So that means that if the price of your real estate drops below $90, you'll get liquidated instead of 75 or less, which you expected. So that's why you want to also put max liquidation threshold value in place to protect against slippage. Pretty standard stuff. And protection is extremely simple. So it will calculate the loan amount. If loan amount is less than minimum loan amount, the transaction will revert, so nothing will happen. So the same goes for slippage protection for liquidation threshold. If the calculated liquidation threshold is greater than max liquidation threshold, again, the transaction will revert. And this is slippage protection, essentially. Do we have? Yeah, we don't have it anymore. Okay, cool. So that's for slippage protection. And yeah, the rest of the function implementation is extremely straightforward. So you're transferring from Alice address to this smart contract the amount, like let's say 5, like 25%, like 5 tokens for that token ID, for token ID 0 to this smart contract, populating the details of this struct, so we can grab the details later. Specifically, we are interested in the amount supplied, loan amount, and liquidation threshold. And as a last step, we're gonna, from this smart contract, transfer the loan amount in USDC to Alice or to message.sender. So for this mini version of lending and borrowing protocol to work, we will need to fund it with some amount of USDC tokens on that testnet, so we can perform actual swaps. Because if you don't have enough, this part will also revert, and we're emitting some events. But okay, let's now see the calculation for normalized valuation. I said that line 83 is one of the most important ones, so you want to focus on that one. But let's see what this get valuation in USDC function does. Let's see if I can go to here. Oh, I can. Nice. So, as I said, and this is extremely important part, $1 is not always equals to 1 USDC, 1 USDT, 1 DAI, or whatever. If you ever see a smart contract that hard-coded these values to 1, or a UI that hard-coded these values to 1, or does not have a protection against DPEGs and whatnot, run away. So you want to make sure that you calculate USDC or any amount actually of stable tokens accurately using Chainlink price fits. So in general case, as written here, $1 is not equal to 1 USDC. The value can actually vary between 0.999 something and 1.011 something. So as I said, it's extremely dangerous to hardcode these values to 1 USDC. And if you care about those last decimal places, there is some kind of arbitrage opportunity maybe, but not a lot. But that's how it works in general case. So what we need to do is to actually implement, because again, I said 3 times, I think already, the price details we are reading from the real estate token, our mock tokenized 1155, are in US dollars, actual cash US dollars from the Zillow API. We need to convert that value to USDC using Chainlink price fit. There is luckily USDC in USD Chainlink price fit, and if you go to data.chain.link and go to data feeds over there and select these are all mainnets, but there's also like feeds for testnets, but this is just for you to view the details of that USDC. Of that feed, you'll here find the USDC in terms of USD feed, and now it's actually exactly $1, which I didn't hope to, but it was 0.9999 something yesterday. But for example, if I go back to to USDT, for example, you will see it's 0.999 something. So you see like stable coins vary in between this range, and here we can actually see the differences. So you see 0.99990, 0.99976, exactly $1, 99909, 99987, whatever. And there was where is 1 point something, I think over here. Yeah, 1.0001. That's what I'm talking about. So it's in this tiny range. So you must not assume that it's always going to be $1. Sometimes it will be like it's currently, but we must not assume that. Cool. More on this later. Let's actually take a look at the implementation of this function. So this is the valuation in USDC, right? So here, first of all, we have a call to get price details view function of that real estate token. And if I go back here and find that function here, so you can see it's blue one, like a view one, it will call this view function and these values will be returned, right? We already saw them. List price, original list price, text test value, all in US dollars. So there will be part of this struct. You can see price details.list price, price details.original list price, etc. Then here is the implementation of the valuation formula. This one. So this is the formula. Let's see, weight times list price, weight, original list price, etc. This is the implementation. These three weights, you can see, are immutable values. And also for simplicity reasons, we hard-coded them in constructor to 50, 30, and 20. So that's 50%, 30%, 20%. So list price, the current list price has the most weight in this formula. Okay. Here we calculated valuation. Then there is a call to get USD price in USD, which is the function that will, this one, that will integrate, that will call the Chainlink price feed. More on that in a minute. So this will call Chainlink price feed and returns us USDC price in USD. So it will currently return 1, but it can be 999,090 or 10001, etc. Okay, so it will return something right in this range. So this is this variable. Then we need to normalize this valuation. Okay, so why is that? So that's the second part. Let's analyze the important part of the code. Working with Chainlink data feeds, decimals. So if we go to this data feed, we can see a lot of stuff over here. The latest price, the network, trigger parameters, we're going to talk about it in a minute. Last update, contract address, oracles that reported price, prices they reported, and when, and a lot of stuff. But if you go to the contract itself, so we're going to open the contract itself here. This is the aggregator contract. And if you go to read contract, this is the proxy, sorry. And if you click to decimals, you will see that the number of decimals for this feed is 8, right? If I go to some other feed like BTC in terms of USD, for example. No, let's see BTC ETH. BTC ETH. And again, this is Ethereum mainnet. So I'm going to read contract. And call the decimals functions. Function will see that the number of decimals is 18. So these two values, 8 and 18, are the most common decimals values in of Chainlink price feeds, but they can be different values. So why is that important? Let's go to the actual feed. Where is the latest answer? Okay, I'm gonna take this value. So this is returned from USDC price in USD. This is returned from the price feed. So it can be this value, or let's go to Tether. Just to grab the different one. Okay, let's lose this one. So if I go here, this is also the same feed. Read contract. Latest answer. Okay, can be like this. Perfect. I'm gonna collapse all of this stuff. And let's put it over here. So this is USDC price in USD. Can be something like this. In T1, it's this value, in T2, it's this value, etc. So, and we saw that decimals, like feed decimals, so this thing will return 8. Feed decimals is 8 for this particular feed. Can be also 18 or whatever. That means that if we get this value, this is how we read it. On this value, we we shift for 8 decimal places to get the final result. So this means that because the feed is USDC in terms of USD, in dollars. That means that 1 USDC equals 1, 2, 3, 4, 5, 6, 7, 8. Or like this. So exactly $1 because of 8 decimal places on the right. So we shift for 8 decimal places. In moment t number 2, 1 USDC equaled 1, 2, 3, 4, 5, 6, 7, 8. So here decimal places, we're going to put 1 front 0, and that means $0.99989,332. So this is why the feed decimals are important. Okay, we also saw that other feed, which was, let's say we have feed BTC in terms of ETH. Ether, okay. Okay, doesn't matter. Ether. And we know, I hope we know from Solidity, that this syntax, 1 Ether, like me, has 18 zeros. So 1, 2, 3, 4, 5, 6, 7. Oh, sorry, 6. So that's 18. 6 times 3. 1, 2, 3. Yeah, 6. So this is the denominator. So if I go again to, let's find BTC in terms of ETH, this one, and let's query it really quickly. Decimals is 18 again, and latest answer is this one. Okay. And go back to Remix, and in T1, the price was 1 BTC equaled this amount of Ether, right? Okay. And let's say that we created another smart contract that allows us to mint an NFT or sell whatever for 1 Bitcoin, like 1 Bitcoin, but it accepts only Ether for that, or like accepts only message.value. So how much message.value you should send? We're going to query Chainlink price feeds, and the answer is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we can see that 1 Bitcoin equals almost 250 ETH at the moment, if I'm not mistaken with this thing. But because both feed, so feed has 18 decimals and Ether has 18 decimals, because both has the same number of decimals, our message.value will be just this, because we're just going to grab the value from the feed and transfer whatever. But here, in our example for USDC, the feed decimals is 8, but the USDC token itself has 6 decimals. So USDC token has 6 decimals, okay? Okay, I saw in a comment it's 24, not 200. Okay, my bad. It's just 1. I missed that. Like, yeah, okay, that sounds more reasonable. So 1 BTC is 24 something. It doesn't matter. But USDC has 6 decimals. And if you go to, where you can find that, let's go to support. This is functions. Let's go to CCIP to grab the token of address of a USDC token. So it's right over here, USDC. I'm gonna open it. Even though I hard-coded it manually in my code, if I go, this proxy should be, Where's decimals? Oh, here it is. Decimals, it will return number 6. Okay, cool. So that means that if I want to transfer 1 USDC, I essentially need to do USDC token dot transfer from Alice, Bob, and 1, 1, 2, 3, 4, 5, 6, 1 and 6 zeros. And this will essentially transfer 1 USDC because of decimal places. That means that if I use this value returned from the fee, which is 1, 2, 3, 4, 5, 6, 7, 8 zeros. So that should be like 1 USDC equals $1. But if I use this plain value, as I did for Bitcoin in terms of USD, I will not transfer 1 USDC. I will rather transfer 100 USDC back to Alice, which is wrong, right? I'll mistakenly calculate more USDC than I should. So to solve this problem, I need to normalize valuation in terms of decimals. And we can see here why we put this section in a Gitbook is important, because this is how you work with decimals when you code price feeds and different types of ERC20 tokens, because sometimes decimals won't match. That was intense, but I hope you understand that. Actually, it's pretty straightforward, but here, I'm going to just collapse this. Here, we're just adjusting the valuation to use from 8 decimals to use 6 decimals. So the calculated valuation in US dollars times the price of US dollars, the price from USDC in terms of US dollar feed, and we are multiplying this by the number of USDC decimals and then dividing with the number of feed decimals times 6 divided by 8. And we always first do multiplication, then division and solidity because of the loss of precision vulnerability that can happen, but probably won't if you just do multiplication. Then division, and finally, we are receiving the normalized valuation value. Okay, and let's actually try to, oh, not yet, we haven't deployed this contract yet. Okay, we're gonna see the actual normalized valuation value later. Okay, okay, cool. Let's now understand the final part, and this is price update frequency. Avalanche mainnet filter USDC in terms of USD. So there are 2 trigger parameters. Okay, let's start with this. So Chainlink data feeds is in the implementation of push-based Oracle model. So push-based Oracle model means you have node operators in a DON, like decentralized Oracle network. This one over here. So this is the legend, like all of these node operators. They will constantly calculate the price of this feed, like USDC in terms of USD. And using peer-to-peer network, they will communicate between each other, like gossiping. Like, okay, this is my price, what's your price, whatever. And they will share their prices. And we can see here, this one responded with 0.999 something, then 0.6, then 0.999871, then this one is 10, then this is 101, and etc. Then they will reach a consensus on the final price. And if that price is, and then it will compare that price with the latest reported price on the smart contract, because when we querying the price feeds, we're just calling the view function on the proxy contract that will query the aggregator contract. And essentially, if you call the latest answer, you will see the latest price. So the new calculated price will be compared against this one. So that's happening constantly. And deviation threshold for this feed is 0.1%. That means that if the new price is below or above this $1 currently reported on chain, we will like the transmitter node from this dawn will push the new update to on chain. And if that happens every single block, it will push it nevertheless. But it's not practical to push new calculated prices on every single block, because it's extremely costly to do something like that on blockchain, and you basically are creating a lot of traffic, which increases the gas prices for anyone, which is probably one of the reasons why we have so many issues with Ethereum Sepolia right now. And for most use cases, because differences are in final decimals or in final two decimals, like pretty small details, most of the use cases won't care about that. So that's why there is a threshold parameter over here. Threshold parameter is not the same for every feed, so you must not assume that this is the same for any feed. Quite the opposite, is different and can be different. The second parameter is heartbeat, and we can see the heartbeat here. You see how it comes down. So if the price does not go below or above the price deviation threshold, there was no new updates. Once the heartbeat passes, and we can see 3 more hours until the new push, the transmitter node for the dawn will still push the new price update on chain. Nevertheless, even though the price is exactly the same as the last reported one, we can see that the heartbeat for this feed is set to 24 hours because this is a stable token, and the price does not change that frequently. However, if you go to some other feed, you might find different values. So we can see that the last update here was 3 hours ago. For some more risk feed, you'll find different parameters, etc. And the same goes for example, proof of reserve feeds. Like, I know we're now mocking this part for our real estate, but in theory, like in the actual use case, for example, I don't know, you're gonna use cash gold proof of reserve feed for whatever reason, and it can have a different deviation threshold and heartbeat threshold. Sometimes it's going to be 1 hour or whatever. So you need to be aware of those. Okay, cool. Let's see how that translates to our smart contract. So I'm going to delete this thing. And here we see that we have a external call to our smart contract that will return these 2 prices. And here it's a call to internal function, which is get USDC price in USD. Here's the implementation of that function. First of all, let's go to docs.chain.link. I know that a lot of you will say data feeds are easy, and they are easy. And then, however, when we have a hackathon, I see multiple times implementation like this. So you hardcode the address of aggregator interface. This is BTC in terms of USD and Sepolia. And you just call the latest round data. Cool, that's cool. Get the answer, return the answer, and that's it. So first of all, you will need to deal with decimals, as I showed to you. This is Bitcoin. So, like this feed in terms of USD, if you're dealing with red Bitcoin, you need to go to grab Bitcoin to see the number of decimals. USDC on the other part, if you're dealing with stable tokens, deal with that. So you need to normalize decimals in first place. Okay. Second, let's do like this. So first of all, this is how you can normalize based on decimal places. And all the aggregators have this decimals function, so you can always query it like this. You don't need to hard code it or whatever. You do need to have a function that can update this data feed, but I'm going to talk about that in a minute. So first of all, besides the actual price, you want to check for round ID. So round ID will never be 0. That's the invalid round ID. If round ID is 0, that means that you're maybe triggering the wrong data feed. You mistakenly put a different address, or you put address of feed that it's on Ethereum, but you're doing this as an Avalanche, and because you switch between codes, you forgot to change that or whatever. Or you're querying the feed that is no longer like it's deprecated. You don't have a mechanism to update to a new feed or whatever. So if for any reason round ID is 0, you must revert, right? Even though the price is not 0. Price can be whatever. Second thing is the staleness threshold. So as we said already, where is that? There are these, okay, this is USDT. Never mind. There is this heartbeat intervals, right? And when you call the price feed, you will see this update at in timestamp. So this will be last update was 6 hours ago. So that will be like a block timestamp of that period of time, like 6 hours ago. Now, for your use case, like let's imagine that something's wrong with this feed, or it's outdated or whatever, and the last update was 3 days ago. This is extremely stale data. This is the old price. And we don't want to deal with old prices, right? And because of that, you want to put the heartbeat or the stale threshold. It can be the same as heartbeat here, or you can be more strict and use your own, whatever. But over here, if I look for this variable, we can see that we're storing that in a storage variable over here, and there is a function to update both aggregator address and heartbeat if we want. So if update at add is less than current block timestamp minus whatever you put for staleness threshold, this will also revert. Like you don't want to deal with all the data. And finally, what I haven't mentioned here, yeah, you always need to use latest round data instead of latest answer, because if you call latest answer, you just get the latest round answer. But with latest round data, you also get the round ID, updated at, etc. So you can start at and update at that. So you can check that this is not 0. So you can check that this is not stale, etc. Because this is the last price, but can be pushed like 3 days ago on chain. And yeah, you're just comparing that. Okay, said that. And finally, you might want to use try catch block here, because again, this function call can fail. You call the address that is not does not have latest round data implemented or whatever. Like this can revert. It's like feed is DDoSed or whatever. It's highly unlikely, but there's a possibility. So you might want to try to wrap this call inside the try catch block. Not necessary all the times. I put this code here just to show you how you can do it, but this is like a last thing that you need to worry about. Also, we're currently on Fuji, but if you are dealing with any L2 with centralized sequencer like Arbitrum, Optimism, whatever, there is also another feed called sequencer uptime feed. So you also want to query that sequencer is up and running, so you can proceed with your computation. And yeah, that's pretty much it. I'm not thinking now, because I spend like a lot of time here. I might write an article or blog post for smart contract design patterns. I'm not sure yet, but yeah, if you want to subscribe, I might. If you think that'll be like a good blog post to have everything in one place, let me know, and I might write it. So that's like another thing. But yeah, that's pretty much it for this function, and for this one, for that matter. Okay, what else we have here in the Gitbook? Nothing more. Okay, So we covered this function, covered this function, covered this. Okay, and borrow. The functions that left to be covered are repay and liquidate. So repay is when Alice wants to repay her debt. She has 60 USDC or 60 more. Maybe she earned some more USDC somewhere, but she wants to repay her debt and wants to get the ERC1155 tokens she loaned in return. So it's extremely simple function. So she will just provide the token ID of that tokenized house fraction of tokenized house she loaned. We will get the details from a mapping, basically return this struct. If amount loaned is 0, there is nothing to repay, so we'll revert. We will follow the check effects interaction pattern over here. So we're having non-reactant modifier over here. We're deleting the entry from the mapping. So first making checks here, then like interactions or effects here. So internal logic inside smart contract, and finally we are making 2 external calls and emitting an event. So we will just save transfer from Alice account the USDC amount loaned automatically. So she needs to approve at least this amount to be spent by our smart contract. Otherwise, it will return. So we're not calculating this. We're just getting that from storage from this struct, because this is already calculated, and we don't want to recalculate again because we want to be consistent. And in return, we're just transferring the ERC1155 amount supplied again. And this is how borrow is repaid. If, however, price of real estate drops below the liquidation threshold, we can see that this is external function, which means anyone can call it. Anyone can call the liquidate function, and it will recalculate normalized valuation again to see the current valuation in USDC. Then it will calculate the amount supplied divided by total supply. So because if Alice was submitted 5 tokens, but there are like 20 in existence, so this is like 25% plus the price. And if that value is below the liquidation threshold, as we hear over here, this is extremely simple thing. Just for simplicity, we will just delete that loan so it doesn't exist anymore. In reality, you want to split liquidation profit between the liquidator and the smart contract itself. That's how Aave and other protocols are doing it. This is just for simplicity. Do not do it like this in production, because, for example, we don't even have like a function to withdraw these ERC1155 tokens from this smart contract, for example, which is extremely bad design, but it's extremely simplified for the purpose of this bootcamp. And that's it. Any questions about any part of this code base? I'm gonna wait for a minute or two. Okay, I see a couple of comments that they would like a blog about that. So, okay, I'm gonna write it. And let's see if where is my Twitter? It's over here. And link is over there. So if you subscribed to this newsletter, you will receive at some point to your inbox the article about working with data feeds at some point. I don't know when, because I have a lot of stuff to do and to finish and to wrap up for this year. But at some point in the next month or 2 or even less, I'll probably write everything I explained to you in a blog post. So yeah, just subscribe to that URL, to this URL. And yeah, I'll drop it at some point. Let me drop it in a chat as well. Yeah, here it is. This is the URL for the blog. Okay, blog aside, do you have any questions about RWA lending smart contract? It's a lot, I know, even though it's like 200 lines only. but there's like some kind of best practices and primitives that I want to spend some time on, because again, this is a medium to advanced bootcamp, so I wanted to show you some of this stuff, which are more production ready than what you can find in beginner bootcamps. If there are no questions, I will proceed with deploying this smart contract, and then I will have a question for you. Okay, cool. So let's deploy this contract to Avalanche Fuji. So I need to provide the address of real estate token. I need to provide the address of USDC token, the address of a fee, and I will provide this heartbeat. Can you do a quick recap without those deep details? I already did it multiple times. So this is a contract that will allow you to send some amount of your tokenized real estate asset and get USDC tokens in return. Once you want to repay your debt, you will supply the same amount you loaned in USDC, and your 1155 tokens will be sent back to you in return. However, if the price of your real estate drops below the certain liquidation threshold, anyone will be able to call the liquidate function, and you will lose all of your 1155 tokens. You can keep USDC. Okay, cool. Let's proceed with the deployment. So I'm gonna compile this once again. I'm gonna make sure I'm on Fuji, which I am. Still compiling. Okay, here it is. RWA landing, all good. So we need to provide the address of real estate token because it will query it for that view function for prices. So this address, the address of USDC. So the address of USDC, I like to get it from CCAP page. So this is this 5 4 whatever. And if you go here, it's again 542. So that's the address. And we can also verify it here that this is USDC, like 5 4, the same thing. So I'm gonna paste that address. Aggregator, the address of the aggregator. So I'm gonna go to docs.chain.link. I'm gonna go to data feeds. I'm going to go to feed addresses. I'm looking for price feed address, and I'm looking for Avalanche. So Avalanche, specifically Avalanche Fuji testnet. So Avalanche testnet over here. And because it's a testnet, I'm going to show more details because, okay, let's not show more details yet. First of all, I want to find the USDC in terms of USD, and here it is, USDC in terms of USD, 97FE. So I'm gonna copy that, or here, 97FE, so the same thing. And this is the heartbeat that I want to provide. And I can get it by showing more details over here. And we can see that for USD, in terms of USD, it's 86,040 seconds. So I'm going, and here 8640. So 8640 over here. Let's okay. And I'm going to hit transact. So MetaMask popped up. You cannot see this, but I'm confirming this transaction, and I'm waiting to include in the next block. Which just happened, confirm transaction, and here's the RWA landing smart contract. Now the question for you, I said that 83 line will be important here, so let's zoom out a bit so you can see the whole implementation. Okay, this is the borrow function. Okay, borrow. You don't need the arguments, I think. So first of all, we want to call the price of USDC in terms of USD, and we can see that now it changed. It's not anymore 1,0,0,0,0,0, whatever. It's not $1. Now it's 1, 2, 3, 4, 5, 6, 7, 8 decimal 0. So 1 USDC currently worth this amount of dollars. Okay, so 0.9. We can see how it changes. So that's why we must not assume it's always 1, even though it was 1. The second is we are gonna get the valuation of this token in USDC. So get valuation in USDC. That's the one function which will call the get USDC get real estate token price details from functions, those 3 values. Use that valuation formula, call the get USDC price field, which is just called, and normalized to 6 decimals, and we should see a value here. So this is the valuation. So normalized valuation, this value, normalized valuation, is, let's collapse this, is this. Sorry. Is this value. Okay, so this is normalized valuation. Let's say now that Alice wants to borrow or to lend, sorry, in order to borrow USDC, to lend 25% of its ownership of this fractionalized real estate. So 25% will be 5 tokens. So 25% or 5 tokens, 5 real estate tokens. How much in return we should, how much USDC in return we should send to Alice? Please drop your thinking in a chat. This is a question for you. Take your time. This is the ultimate test. Have you understood everything I said? I was saying for the past 30 minutes, I think. Slowly, easy. So how much USDC roughly, or at least formula, or how to calculate it, we need to send in return back to Alice? All the code is here at the screen. We have time, by the way, so I won't rush you. Okay, cool. First of all, we have a text for Joran or Joran. I'm not sure I pronounced that name correctly. I'm sorry. He said, or she said, 189K USDC. Okay. We now need to somehow verify, to recalculate whether that amount is correct. How we should do that? So we can be sure that this person hasn't just typed random amount, which I assume it's not, but which formula or how we should calculate how much USDC we can get. Nice, even better, we have with decimals. So he definitely calculated this. So roughly 189.393 USDC should be sent from this contract. But you don't think for yourself and drop in a chat why do you think this amount should be sent and how we calculate it and etc. So this is the normalized valuation we got from calling the contract. So this is what smart contract calculated for us. Alice wants to lend 25%, like 25%, not the whole amount of the whole fraction of the house. So that will be 5 tokens because we minted yesterday 20. So 5 is 25% of 20, and this is how we should calculate it. Okay, cool. We saw here from Thibault, that he calculated that the valuation we got by calling that function get valuation USDC, as if I go back here, if I go back over here, okay, so this function returned that, so he multiplied that by 5, which is the amount, and total supply is 20. So this is normalized valuation. This is 25, and yeah, sorry. This formula will gives us the normalized valuation. However, that will be like for 100%. That'll mean that no matter, like, that'll mean that price below for even a percentage down, we can liquidate Alice. So because of that, she needs to get only 60% of that value. And as Rami said here, so of that value of this one, that of normalized valuation, we need to get only 60% of that value. So this, and also there is, Kai said, you need to convert that to USDC. This function, valuation in USDC, already converted this to USDC. So this is in USDC. So this is USDC. Then we're multiplying this by 5, which is the amount, dividing by 20, because that's 25%. So let's calculate that, shall we? Calculate, or let's, yeah, calculator. Let's do. So that's what? This amount. Can I type? No. Oh, come on. Okay. That'll be 75777. Oh, this is painful. 4304145. I hope I don't have typos. If I have, I'm sorry. So we're gonna multiply that with 5 and divide this with 20. And we got this value. Now we also need to, so this is 100%. We need to calculate 60% of this value over here. So times 60 divided by 100. So 60% times 60 divided by 100. Okay, so this is the USDC amount. Let's see if I can grab it. Okay, so this is loan amount. So now loan amount is this value. If this value is less than minimum loan amount, it will revert. But essentially, we can see here that we are transferring loan amount back in return. And since this is USDC, finally, that means that this amount is 1, 2, 3, 4, 5, 6. We put here. So that'll be okay, like this. 113K something, which I think someone posted over here. So roughly this amount. Okay. However, if we go to Circle faucet, this faucet gives us 10 USDC. So in order to not spam this faucet, and we most likely won't get this amount of USDC easy, even though if we somehow manage to spam it, we're gonna conclude our exercise here, because we're not gonna do the actual borrowing on chain, because like it's ridiculous. So what you can do, if you want, you can try to implement this in a local environment. So you can fork mainnet, testnet, whatever, and then your founder hardhat test, you can easily play with this. Or as a workaround, if you still want to see this in action, instead of when you're deploying real estate lending over here, instead of the actual USDC token, create your own mock USDC, some simple ERC20 token, which will have which will have 6 decimals, and you can endlessly mint that token. So if you go to, for example, Wizard open Zeppelin or something, so that smart contract might look something like this. So that'll be mock USDC. So mock USDC. You can pre-mint whatever amount of you want. However, whatever. And you can also make it permit is important because USDC is also has permit. You can make it mintable if you want, and you will just need to. Oh, okay. I cannot edit this, unfortunately. That's unfortunate. But let's say mock USDC.sol. And you can also emit function decimals, public view, I think, returns unit 8 should be, right? And you will just return 6 decimals, right? And what's wrong with this? Override, okay, public override. And yeah, that's how you will implement it. And then because you can mint this token endlessly, then you can play with it on testnet. You're still going to use the actual USDC data, but you don't need to spam USDC faucet endlessly. So yeah, because first of all, you probably won't be able to get this amount of tokens anyway. And second of all, you must never just spam faucets and grab tokens. Like, tokens are for everybody. There are much easier ways to test stuff in Foundry and Hardhead. There's all, especially Foundry, really powerful development frameworks, and you should spend your time there and test everything there. Testnets are just for final UX testing, in my opinion, at least. Okay, cool. That was exercise number 1. Any questions that are not already answered in a chat? Because I saw you're now discussing between yourselves. And yeah, could we change threshold for testing purposes instead? Well, no, because these 3 values returned from Zillow API are high, because that's the value of mock real estate. So it won't influence that much. I mean, you can set, I don't know, wasn't an initial threshold to 1% or whatever, and it's going to be a really low number. But it's better to do with your own mock token or in Foundry or Hardhead. It's much easier, and that's how basically people that are writing production-ready contracts are doing their testing, not in testnets. Okay, cool. So quick break, like 30 seconds break, and we are gonna start with exercise number 2. So for homework for this one, you can just deploy RWA lending to Avalanche Fuji. That's fine. That's enough, because you can play with it, call these few functions to see the calculations. But if you want to go a step forward, you can create your own mock dummy version of USDC and play a bit on testnet. Do not use actual USDC. These are ridiculously high amount of tokens. So yeah. Cool. Exercise number 3. Exercise number 3 is actually quite simple. And as I said, we're going to just create an English auction to send a fraction of this real estate tokens. Because again, if you use ERC-71 standard, you will need to transfer the whole token, like ID 1 or ID 777, and that's the whole portion. The powerful part about 1155 is that you can represent that fungible asset with certain amount of non-fungible tokens, effectively making that fungible asset a fractionalized asset. And I said that I don't know how many times during these 2 days. And we are going to use this feature of ERC 1155 standard to create an English auction where Alice can sell this famously 25%, like this 5 tokens, to the highest bidder, and it will receive native coin of that blockchain, AVAX in our case, or ETH, Ethereum Sepolia, in return. So there is also, as I said, besides English auction, there's also Dutch auction. These are the 2 most popular decentralized auctions. There's some more, but essentially these 2 are the most common. We decided to go with English auction because it's a bit easier. So here how it works, at least this minimal implementation. So Alice will deploy this contract, and whoever deploys this contract will be a seller. So it's not like the general purpose auction. This is contract that specifically Alice created to sell her fraction. It's just for her. So it's not general purpose. For general purpose contracts, it will be bigger and have more features, and I wanted to keep everything minimal and simple so it can fit on screen while I'm sharing the code, and it's not that hard to follow. And let's say that's Alice. Okay, when Alice calls the start auction function, we will see the start auction function. The contract will lock, automatically transfer the portion of ERC 1155 tokens she holds inside it. She specified like that percentage. Our auction lasts for 7 days. That's hard-coded. So during the next 7 days, anyone can bid. So the bidding is in native coin only, like message.value, and anyone can bid by depositing amount greater than the current highest bidder. All bidders can withdraw their bids, excluding the current highest bidder, obviously. So whoever is the current highest cannot like withdraw its own bid logically. If I'm not the current highest, I want my bid. I want my coins back because like I want buy or get these fraction of real estate tokens after the auction ends. After 7 days, the contract is designed that anyone can call the auction function, like anyone, even like Chainlink automation, we can automate that, which will transfer this fractional real estate tokens to the highest bidder and the highest bid back to Alice. So inside the same use cases folder, again, inside a folder, name it however you want, create the English auction.sol file. And I'm going to copy the content and we are going to analyze this contract. So inside artifacts, use cases over here, English auction.sol, paste it, compile, and here it is. If you're interested in Dutch auction, you can go to Solidity by example. It's a really good website. And here should be somewhere Dutch auction. So this is English. So the code is pretty similar to ours. And this is Dutch auction. Like the difference is that these auctions are for NFTs. So this is the main adjustment we needed to do. And this is how Dutch auction works. Essentially, you can just Google them. It's a slightly different primitive, but you can definitely do that with this real estate token.sol. So that can be even like a nice exercise if you want to go beyond this workshop and this bootcamp. Once we implement English auction, you can maybe try to implement Dutch auction by yourself. That'll be like a good example, like not for homework, like not be necessary for certificate, but the secret to becoming a great developer is just practice and coding and repeating 10,000 hours, whatever. So you can just use this smart contract, which is for NFTs, and try to adjust it for our real estate token, which is 1155, and you can grab some ideas how you can adjust those by following the Chainlink Function smart contract. So if you want to go beyond, so you can create that for homework and maybe post it in Discord or whatever. Tweet it, tag me. Okay, cool. Let's understand the English auction smart contract. So this one as well has implemented this ERC 1155 receiver, because this contract as well will need to be able to receive ERC 1155 tokens, and implementation of on ERC 1155 received and on ERC 1155 batch received and supports interface are exactly the same as in our RWA lending. So I'm not gonna explain them again. Extremely straightforward, but you need to be sure that message.sender is the actual real estate token, at least. Cool. In constructor, we, as I said, setting this immutable variable seller to Alice, to message.sender, to whoever is the deployer of a contract, and we're just providing the address of the real estate token dot as well, smart contract. When we call the start auction, let's collapse this. So start auction function will again follow checkFX interaction pattern. If auction is in progress, it will revert. If message.sender is not seller, auction will revert. So Alice will need to call it. Then it will transfer from Alice address, from seller's address, to this smart contract the certain amount of tokens for a specific token ID. So in our case, that will be token ID 0, amount is 5 for 25% of 10, or 10 for 50% or whatever. Data will be empty because we're not utilizing data, but you can definitely explore if you want what data has to do with in the context of ERC 1155. It's actually a great thing. And finally, we're gonna put the starting bid. So starting bid in with 18 decimals. So because of the message.value in the native coin, right? So if we want to sell this for 100 AVAX, there'll be 1 and 20 zeros as a starting bid. And the rest is we're just setting this flag to true, and timestamp is from the current block timestamp plus 7 days. So auction lasts for 7 days. And we're just storing some details about the token that is on auction, the amount that is on auction of fractionalized asset, the current highest bidder, and the highest bid are just a starting bid and message.sender. That means that if Alice is still the highest bidder, she will be able to just get her tokens back in return, because she hasn't sold it to anyone, right? There is a view function to get the current ID of a token that's on auction, so you can interact with the real estate token as well by yourself. And for example, you might want to do something like this. So let's collapse this, expand this, sorry, let's actually zoom it a bit. So this is a real estate token. So here you might, okay, this is the one, this token ID is on auction. Okay, I want to see more about it. So if I go here, URI, okay, this is the IPFS hash. Now, if you go to IPFS hash, I can see details, number of rooms, bedrooms, total prices, picture of that house, whatever. Okay, I want to bid for this fraction of tokens. This is interesting to me, etc. How can you bid? This is the implementation of a bid function, and it's extremely simple. First, we have some checks whether the auction is in progress, whether it's not ended, right? And if it's past 7 days, and whether your bid is actually greater than the highest bid. If not, we'll just revert, because you must bid with the message.value amount that's higher than the current highest bidder. And this function is payable, because this function, payable in Solidity, means that this function can accept native coins. The rest of the function is extremely straightforward. It just updates highest bidder details and the current total bids mapping, and yeah, that's pretty much it. If you want to withdraw bid, if you're not the highest bidder, so if you're the highest bidder, you cannot withdraw. If you're not, you're just going to grab the total bids you placed so far. So that's why we have this mapping, the total bids you placed so far, and we're going to delete that mapping and send those coins back to you. This is the preferable way to send coins, native coins in Solidity. I think you can pretty easily find on multiple different places on the internet why, but this is how you should do it. This is the safest way. And if this failed, we'll revert. Finally, for our final function is end auction. As I said, after 7 days, anyone can call it. And by calling this function, it will automatically resolve to send ERC1155 tokens, like fractional points of that house, to the highest bidder, and highest bid back to Alice in native coin, in AVAX in our case. And yeah, that's pretty much it. So I'm going to deploy this smart contract. I'm going to put it on auction. I'm going to send the address. So if you want, you can bid for a fraction of my real estate if you want, if you have time. But for homework, you can just play with it, deploy it, start auction, try to bid with different wallet or whatever. If you can maybe play with your friend, you can bid or whatever. Okay, cool. So let's compile first this smart contract. And the only address that I need to provide as a function argument is the address of real estate token. So I'm gonna hit transact. I'm gonna deploy the smart contract to Avalanche Fuji. I'm gonna hit confirm. I'm gonna wait for transaction to complete. Okay. There is a question, right? Token ID on auction. Have we updated that yet? Okay, cool. Yes, we did. Okay, so the question is, the value returned by get token ID on auction is 0 by default. So it will refer that the token ID is available for auction by default. No, it will return this storage variable, and I just searched for it to see have I not forgot to put that, but I haven't. So when you start auction, you said, I want to sell this token ID on auction, and it will return that value because that'll be locked inside a contract. In our case, it will be like it's 0 because we all have like token ID zeros, but in general case doesn't need to be. I hope that answered your question. Okay, so where is English auction? It's over here. Let's hide this comment. Okay, so there is a bid function, there is end auction, withdraw bid, etc. So currently, it's 0 because there is no, that's the default value. But I'm gonna start the auction. So before this function will also revert if I don't approve this smart contract to spend my tokens first. So what I'm going to do here is I'm going to go back to real estate.SOL smart contract. And there is approval somewhere. So that should be burn batch, set approval, this one. Yeah. So I'm going to set that as a true. So this should work, right? If not, I'm going to go back. Okay, so this will allow. Yes, I'm going to approve this. I'm going to wait for the transaction to complete. And here, token ID, I'm going to put 5, like 25%. For data, I'm going to put empty. And starting bid, we can do, let's say, 0.1 AVAX. Okay. So that will mean that I need to provide how many zeros? This has 18 decimals. Anyone in chat, how many zeros for 0.1 AVAX? There's a question, by the way. Okay, Valerio said 17, Thibaut 16, Ricardo 17, Mauricio 17, and yeah, the correct answer is 17. Yes. So 1 and 17 zeros. Okay, let's count. That'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so I'm going to put 0.1 AUX as a starting bid. And I'm going to hit transact. So now you should see the MetaMask pop up. My remix froze. Great. Looks like my remix has just froze. Let's do one more time. Oh, I have an error here. Okay, let's do it like this. Okay. And yeah, this will start my auction. And yeah, that's pretty much it. Again, you can, if you want, start the auction. But what was and play with your friends, but it's not necessary. Again, you can just deploy the smart contract and send the address of that smart contract, because we have all this issue with testnets. We don't want to have a lot of transactions with these gas prices. So for you to complete the homework, deploy auction.sl and just submit it via this form. But you can anyway, like you can play with it. And yeah, that's pretty much it. Now I'm gonna answer some questions. We're gonna play some music, and you will have exercise time, so you can deploy both RWA lending and English auction.sl on Fuji or other testnet of choice. But it's more importantly that you understand how these use cases work and to be inspired of what can be built with tokenized real estate. So it can be much more than just lending and borrowing. If you want to practice a bit, you can implement Dutch auction besides English auction from scratch in Solidity using the same contracts, etc., etc. So yeah, let's answer some questions and let's play some music. I'm gonna play the same one from yesterday. I hope that's fine. If it's too loud or not great or whatever, that's just tell me in a chat. So now is officially exercise time. We have around 40 to 45 minutes for exercises, and after that we will have a talk with the Bricken team, specifically with their CEO and co-founder, Edwin. So I'm gonna continue answering questions, and after that we will have Edwin joining us. Okay, questions. Let's see where we start. Well, if someone was not the highest bidder and do not ask for the bid in return when the auction is finished, they still can ask for the funds to be returned. Okay, let's see the actual implementation, shall we? So, withdraw bid says, if you're not the highest bidder, you cannot withdraw it. If you are highest bidder, this will revert. Otherwise, it will grab all of your bids. And if you don't have any bids, it will still revert. But if you have, it'll just gonna transfer back your coins to you. So it doesn't matter if the auction has ended, you can still withdraw your bids afterwards. So I hope that answers your question. 17. Andre, are you deploying on Fuji as yesterday? Yes, I'm deploying on Fuji as yesterday because that's where my contracts are. You can deploy to your test network of choice. but you need to deploy everything and make sure that all of those 4 Chainlink services are available on that testnet. Who validates the transactions there, and where should we get the contract addresses for the homework? For the homework, you will have this type form. You'll click on it. It's gonna take 1 minute. This is your email address, and then you're gonna enter token addresses for each of contracts. You're gonna enter contract addresses here. It says on Avalanche Fuji, as we said, can be whatever testnet of choice as long as it's like the same testnet. So in my case, actually, okay, I can fill this. So for my case, this is my email. My real estate token address is this one. Real estate token address, this one. So I'm going to hit enter. My issuer smart contract is issuer is this one, so I'm gonna paste that. RWA lending, this one, enter, and English auction, this one and this one, submit. And congratulations, I submitted. Okay. So let me see. Okay. That's how you can submit. And who validates the transactions there? That will be me. So after that, we're gonna collect all your submissions, and then I'll grab your addresses, and then, for example, let's grab my real estate token SL once again. And I'm gonna grab here, and okay, I can see I have some transactions, some contract. Okay, you have not, I have not like verified on Explorer, but I can always load it in Remix because I have a source code and I can expand and see all of these transactions. And I also have like an ABI, so I can easily go to Tenderly and see what's going on. And after all that boring manual work, I'll confirm that you created function subscription, call the issue function, call the update details function, etc., etc. So yeah, that's how it's going to work. It's going to be extremely manual work for me, but it was the same as for CCIP Bootcamp. So yeah, it is what it is. You're gonna wait for a bit, unfortunately, but eventually we will send you certificates. Music, okay. Thanks a lot for explanation. You're welcome. I'm glad this was useful for you. I don't need to remind everyone to pin their contracts. We're not dealing with CCIP, so yeah. Okay. Balance for the homework. For the homework, can we deploy those contracts to networks other than Sepolia? Yes, to any testnet you find convenient. Just make sure that these 4 features of Chainlink platform services are available, and you can grab them by go to quick links. Anyone, wherever you land on the docs, you can always click on quick links. Literally any page, quick links is over there. And you'll need to make sure that CCP, data feeds, functions, and automation exist on that testnet. There's like plenty of them, and you can use that testnet. Can you share the link with the music and playing? I don't have it. If I found it, I'll share it. Maybe on Twitter, on Discord, but I don't have it at the moment. If we all deploy to Avalanche Fuji to homework, is it okay? It's okay. Can we see the minted NFT on testnet? Yes, but the metadata won't be there until you publish to IPFS manually, but technically yes. Great, finished. Thank you, Andre. Thank you, Gabriel. Nice job. Once we review your homework, we're gonna issue on-chain certificate of completion, and we're gonna send it to your email, the unique link, so you can mint it. Why start auction is getting reverted? Let's find out. There might be an error. We can take a look at the code. I'm gonna take it in a minute. Doing tomorrow all the exercises and then fill the form. Thanks. Yeah, thank you. You can do it until October 4th, and I think, yeah, this is the deadline, October 4th at 11:59 p.m. ET, Eastern Time. Can you explain why you need to pin with CCP? Yes. So if you are working with Remix, you can see here that I've connected to injected provider MetaMask. That means that if I switch, you cannot see my MetaMask pop up now, but if from my MetaMask I switch to different network, I will lose my deployed contracts over here, because they now do not exist on that network. If you want to avoid that from happening, you just click pin here, and for each contract you want to pin. That means that when you switch to different test network, they will again be removed. But when you go back to Avalanche Fuji, switch again, do something, and then switch again, here under pin contracts section over here, your contracts will be visible again. And that's useful for CCP, because with CCP you switch between networks multiple times in Remix. How would we receive the certification? You will receive the unique link and all the other details using emails. Like when you fill up the form, the first step is to provide your email to that email address. We will send all the details. Diogo said, thanks for the bootcamp, all contracts deployed and tested. Congrats, nice job. Thank you for joining. And I hope you're all gonna fill the form so we can send you the certificate. Thanks for the bootcamp, Andre. You're welcome, DL Tech. Is CCP built on top of other technology like Cosmos for interoperability, or is it Chainlink native? It's Chainlink native. You can see more details in the official docs. So if you go to docs.chain.link and CCIP, there are a bunch of conceptual overview, architecture, etc. A lot of stuff. And we also had CCP bootcamp recently. So you can probably find the Git book for that one. And we also had like 4 CCP masterclasses. So you can find a bunch of details if you want to really deep dive into it on both docs and previous bootcamps and masterclasses. But yeah, short answer is it's Chainlink native. It doesn't have any external dependency. Yesterday you mentioned that you can transfer value between public blockchains and private blockchains. Can you give an example for each of them so we can test those solutions in real scenario? So yeah, CCIP is currently supported and for a bunch of different private bank chains, both main and testnets, and there's like a lot of testing over there, etc. However, those config details are not live yet. So in real scenario, you can just test between testnets that are publicly available on the docs. But once those private chains are like config details are available, and you know with whom you can interact with, yeah, you can use CCP for that. But yeah, various different bank chains are already testing CCP with their own tech and their own data they're sending. So yeah, that's still a work in progress. And obviously in the future there will be like non-EVM chains, EVM chains, and private and public, and everything's going to be interconnected. But for now you can just test with chains available over here, or you can even test everything locally with Chainlink Local, but that's another topic. But you can test CCP locally using Chainlink Local, which is another tool of ours. And also you can find more details about Chainlink Local over here if you go to resources, and there is a dedicated docs page for Chainlink Local. That's me. So yeah, that's it. Share your playlist. Yeah, once I have it. I don't know. Thank you a lot for the bootcamp. I've learned a lot. Thank you. I'm glad to hear that. Thank you for joining. Yeah. And I hope I'll see your name your email, sorry, under submissions for the homework. Yeah, thank you. You're welcome. I'm really glad to see that this was useful for you. We tried to make it useful. So yeah, at the moment we have exercises in progress, exercise number 2 and 3. If you have any questions about them, feel free to drop them. I'll try to answer them, debug them, etc. And shortly we will have a guest lecture, a talk with the Bricken team, with their own CEO and co-founder Edwin. So we're still gonna listen for a bit of lo-fi and answering questions. And after that, we will see some real use case. Like this is all about tokenization and real world assets and digital assets in production. So you can see how these guys actually do stuff that are like more advanced than what we than our mock examples for the past 2 days. Yeah, thank you guys. Thank you very much for all the nice words. That means a lot. Okay. Oh, I lost my questions. Let's see. Thank you so much. Apart from deploying the smart contracts for day 2, do we need to interact with them in any way to satisfy the homework? So for homework, you can just deploy them, and they'll be fine and enough. To me, it's more important to understand what's written there and how you can write your use cases and to inspire you. And because we had all these issues with gas and testnets, we want to minimize the amount of transactions, because there's like a lot of you that sign up for this bootcamp. But if you want to play with, you can, but it's not necessary. For day 2, for exercise 2 and 3, just deployment is enough. And as I said, you can also, if you want to go beyond, you can play with it and recreate Dutch auction from scratch for this tokenized asset. If you want, it's not part of the homework, it's not mandatory, it's nothing. You can tweet about it, you can put it on Discord, you can say, okay, I follow this bootcamp, there was English auction, but I went beyond and I implemented this Dutch auction because it seemed really fun or whatever. But yeah, that's it for that. Okay, cool. Thank you for this bootcamp. It was very informative and super practical. I'll keep working on experimenting with the contracts. Thank you very much, Fractio, for joining us. I'm glad to see that was useful for you. I'm looking forward to your homeworks and maybe Dutch auction implementation. We'll see. So yeah, keep practicing. 10,000 hours, that's all it needs to master the topic. Okay. Tokenize the world, yes. What value did you provide for set approval for all? Token ID 0 and 5, I think, for the amount. But yeah, and address of English auction contract, I think. Dushan said, thanks a million, Andre. Great and valuable learning in the last 2 days. Thank you for joining. I'm really happy to see this positive feedback, and as I said, hopefully to see your email amongst the ones that completed the homework, and maybe you can implement Dutch auction as well. We'll see. Okay. Thank you. Okay, cool. And as I said, exercises 2 and 3 are currently in progress. Take your time. For homework purposes, you will just need to deploy these 2 contracts, and that's it. They'll be a valid homework for exercise for day 2. So take your time, and afterwards we will have a guest lecturer from the Bricken team. So he will join us shortly. And as I said, you will hear more about what Bricken is and does and how they use real-world assets in production. So more advanced contracts and content coming soon. Again, if you have any questions about anything that we covered today, feel free to drop them in a chat, specifically about some technical implementations. I assume some stuff in RWA lending are interesting, at least. So yeah. What with the real estate tokens? Well, with this mock minimal implementation, it will be just locked in a contract forever. But in reality, you will need to have a way to unlock them somehow. But essentially, you want to split the profit between the protocol itself and the liquidator. So you have incentive for people to liquidate positions. So yeah, thank you, Ronnie, very much. One project I'm interested in is energy RWA tokenization. Are there any projects focused around that, and what are something you will recommend when coming up with solution? I don't know. There might be some build projects doing that, but I'm not sure. I don't have any info at the moment. I can though ask and try to find it, and then maybe let you know on Discord. But yeah, that's a hard problem to solve, definitely. So I don't have any technical recommendation on top of my head, but definitely doable. So yeah, I'll need to think about the implementation, and yeah, I'll need more details from you, of course. But yeah. Okay. So we will soon have our guest lecture from the Bricken team joining us. So you still have some time to finish the exercise for today. If you don't finish in time, doesn't matter, until you have time until October 4th to finish, and also you can ask questions on Discord. Hey Andre, sorry, in case someone already asked, is the certification a POAP, NFT, or different? Yeah, it's a POAP. It's gonna be a POAP on Agnosis chain, so you can mint it there for free, and then if you want, you can migrate to Ethereum mainnet if you want. It's up to you at that point. So yeah, we will send you the unique minting link to your email, and then after that you are in charge of minting them. Same as for POAPs. Pretty standard stuff. And yeah, this is how it looks like. Where is it? Yeah, it has this nice animation. So it's pretty. I like the design. I like this design more than design for CCP Bootcamp though. So yeah. So yeah, stick around. We're listening to some lo-fi music. We're doing our exercises for homework, and soon we will have our guest lecturer join us from the Bricken team. Let's see. Keep getting. Two questions. Okay, first one. Why is CCP needed for liquidity in other chains and abilities, and after RWA is tokenized, then the task ends there? Please enlighten. Yeah, well, thing is that to successfully tokenize your asset, you can tokenize on one chain, but if you cannot move it across blockchains efficiently, you're kind of missing out, because there might be a buyer over there or a different protocol over there for lending, borrowing, whatever, for auction, or you might want to interact with a private chain, or they want to buy something from you, etc. So Technically, yes, it's possible it's just on one chain, but in reality, for production use cases, you kind of want to be on all chains using CCP in order to get the most out of your tokenized asset. Getting the error contract creation code storage out of gas. So you need to enable compiler, optimizer, and compiler to 200 runs. You need to set EVM version to Paris, and you need to have enough of testnet coins to cover for gas fees. Just to make sure, I did deploy Avalanche Fuji, but I'll deploy English Auction on Sepolia. Well, I try to deploy English Auction on Fuji as well, because you will need the address of real estate token data, so a smart contract, so you cannot just put an arbitrary address there to play and all. So you want to do it on a testnet where your tokenized real asset is, essentially, because all of these use cases are linked to your tokenized real asset. That's why on day one we spent all day like tokenizing it, and then on day two just creating multiple use cases out of which we can come up with more and more and more use cases after day one. It's really not that hard. But yeah, just make sure to be on the same blockchain, whatever the blockchain test network is. You're welcome. Cool. If you have any questions about everything we covered during past 2 days, feel free to drop them in a chat. We will also have, as I said, Edwin from the Bricken team here joining us. You can also ask question to him, like he will have a Q&A session at the end. So stick around if you want to hear more about some real stuff in production. And until then, I'm gonna answer any questions you might have, help with debugging, and we'll listen to this nice lo-fi playlist. Okay, this is a good question. We can tokenize a lot of off-chain stuff, but who is responsible for off-chain documentation? And yeah, that's part of the step 5 tokenization, as I think I shared here, this page. And yeah, that's part of step 5 of issuance, and step number 5 is out of scope for this bootcamp. So yeah, out of scope for this bootcamp. And yeah, it's a hard problem to solve, definitely. But yeah, it's not much of a technical problem, although like Deco might help, but yeah. So yeah, I hope you enjoyed this playlist. I certainly do. And I might actually cover this while we're waiting for more questions. This is the last page of the Gitbook with the next steps. So this is also useful if you want to continue your learning journey about Chainlink platform. So the first step is you can join us at SmartCon. This is the premier annual event. This is the annual Chainlink conference, which is happening at the end of the October in Hong Kong. 30th and 31st October are the main conference days, but on 28th and 29th, we also have a hacker house. So following this link and scanning this QR code, you can register for SmartCon. Following this link or this link, you can register for Hacker House, so event which is happening 2 days before the main thing. During Hacker House, this is an event specifically crafted for developers. During Hacker House, you will have these certifications in progress, Chainlink certifications in place. So if you're interested in obtaining Chainlink certifications, we will have something for you during Hacker House. So you can listen to the live classes about certifications on the day 1. And then on day 2, you can take the exam, take the actual test in person on site in order to earn a certificate. So there will be some technical research, a lot of workshops and talks, some happy hours for networking, and you will have the opportunity to connect with the recruiting team from Chainlink Labs and some of our ecosystem partners at the Talent Happy Hour during the first day. So at the end of the day one, there will be an opportunity for this type of networking, which I think is highly valuable. So we can see the whole schedule over here. On day one, after opening ceremonies, there will be some talks, workshops, and certification courses. You will have lunch provided, and there will be more talks and certification courses, again, until 6:30 p.m. So all the content you need to pass the certification. Then there will be this talent happy hour and networking dinner. So this is the time where you can talk with the recruiters from the Chainlink Labs and some of our ecosystem partners. And also there will be happy hour where you can just network with all the other participants over there. On the day two, there will be breakfast provided, and then we will have the certification exam prep for blockchain fundamentals and Chainlink fundamentals. So there will be two certifications, blockchain fundamentals and Chainlink fundamentals. Is nothing too hard. Like it's fundamentals. No worry, guys. Like you can pass that, I'm sure. But after that prep, there will be a lot of talks and workshops just explaining all that stuff. After that, there will be a lunch, and then from 2 to 4 p.m. you will take the certification exams. Like in real world, you will take the exam like there on site in Hong Kong, and then there will be like closing remarks and whatever. But there will be like a reviewing of all your exams and potential to get to get certificates. So that's about Hacker House. You can obviously sign up for Chainlink developer newsletters to stay updated, and you can get in touch. But more on that later. As we promised, we will have a talk with the Bricken team. So I'm gonna quickly now turn off this lo-fi playlist. So exercise time is done. If you still haven't completed your exercises, you have time until October 4th. It's not too hard. As I said, it can be on whatever testnet you find convenient. And now, as I said multiple times, we have a guest lecturer, the CEO and co-founder of the Bricken, Edwin, is here with us. He will talk, as I said, with you more about what Bricken is and how you can actually work and build with real-world assets and tokenized assets in production. So these are the guys that like actually do some stuff in production with real-world assets, and we just created mock versions for educational purposes over here. You can definitely connect with the Bricken team and Edwin himself on Twitter and webpage. And now, if Edwin is ready, I would like to bring him on stage. So welcome, Edwin. Can you hear us?
Yeah. Thank you very much for having me.
That's it.
Already, right? Yeah, thank you very much for having me. It's a
now
pleasure
going
to
to
be
just
here with
stop sharing my screen, and I'm gonna stop sharing like this. I'm gonna add your screen to stage. I'm gonna go back to the background. The floor is yours, and good luck.
Perfect. So thank you very much for having me here. An absolute pleasure. So yes, my name is Edwin Mata. I'm the CEO of co-founder Bricken. Bricken is a tokenization platform that is under the build program of Chainlink. We have been with the build program for a year and a half, I believe now. So it's been an absolute roller coaster to see how a lot of new companies are jumping into the space, banks, family offices, asset managers, real estate, you name it, right? So it's all about the digitization and tokenization of the space. So I'm hoping that over the next half an hour, I'm able to transfer all of the excitement that thrills here in Bricket about the tokenization of real world assets, but also to comprehend what is coming and why. I mean, in the end, as a builder, you have to find a problem that you want to solve. And here, Bricken, we've been building our solution for over 4 years. So it's an absolute pleasure to share a little bit of the know-how that we may have. And I'm saying little know-how, and that's going to make a lot of sense on my next slide, right? Because real world asset came to be as a term around, I would say, 2023. Before that, it was very diverse. Some will call it just security token offerings, other will call it just cryptocurrencies, other will call it just digitized assets. So it was not well defined what a real world asset was. And now it came to be that it was what we call the off chain value, right? So if we were to understand what is the total amount that is offline, it's impossible to measure. Saying impossible seems like a very broad word, but in the sense, there's so many assets still out there that are not even online. So forget about the chain value, right? Talk about all those assets that have no value online. So, for example, there's a lot of still real estate streets in many countries that don't even have an address. They're not in a registry. Land that has not ever been valued, so it's impossible to comprehend how to put it online. We have a lot of exotic values out there, gems, minerals. So, if we were to amass all of the real world value, we're talking about trillions and trillions of locked value, right? So then we have all of the big next trend, which is kind of like all the online value, right? So there's actually real estate that is measurable. There's stocks that are measurable because they're in a stock exchange. But then there's private markets that are not really fully online and not yet publicly disclosed, value of companies who are not there. So even in the online world, which is still a trillion or multi-trillion euro market or dollar, we still don't have a pure value, right? Because the measurement, it's not so simple. Thinking about a startup who raises money, the valuation is provided by the investors, so you can comprehend what is the value, but that yet is not fully disclosed, and it's a valuation made by the company itself. But then, what about all those companies that don't have founders or don't have startup or capital? Or what about the normal restaurant on the corner who provides value? So even if you have a digitized asset, it's still very hard to measure. So we go from a infinitive locked value who is not online to trillions of locked value who is very hard to comprehend. So this is where the tokenization comes, which is kind of like just the one less than 1% of the total value of the world locked now comes into the tokenized version. And why would you tokenize an asset? Because all the pains that I've been speaking for the last 3 minutes are gone. Basically, you do understand at all times in real times what is the value of an asset, where is it located. There's a lot of transparency. What are the moves? Who is trying to allocate value? Is it locked in the chain? Is it locked? Like so many questions that you may have when you go to an offline to an online. In the tokenized version, there's a lot. And obviously, if information is symmetric, that means between buyers and sellers, they both have the same information, it becomes an efficient market and it becomes accessible. So all of this is the reason why we always hear or listen that it's becoming liquid. So I want to be a little bit transcendent here because this is one of the biggest terms that is being thrown for real world asset, but yet it's one of the most dangerous ones in the sense that we're playing with information. The liquidity value is because the information between buyers and sellers, so the market comprehends that there's value and there's an exchange of value between stables to the asset or between euro to the asset. I mean, liquidity is not formed for the digitization phase. What you do when you tokenize an asset and we say it provides liquidity is because you truly unlock the value, right? So this is where Chainlink excels with all the oracles and being symmetric with information, with the price feeds, trying to really comprehend what is like the microsecond value of such assets. Because when you start playing with liquidity, you want to have the real time value of it. And that's where liquidity and all these things come. But it will make sense over the next couple of slides. But I really want to for you to comprehend the magnitude of the things that we're talking about when we talk about real world assets. So from a pure offline locked value, we go to a semi-locked value between parties who sometimes is public, such as public traded markets like Nasdaq, Euronext, whatever, to the tokenized version where everything just becomes purely transparent, more symmetric, more efficient, more accessible, and all of these great characteristics that blockchain by itself brings is the reason why liquidity is unlocked. It's easier to transact and for people to enter into these markets just because they have more access to the information. So this is how markets are created at all times. It's between one person telling the other one the value is A and the buyer saying, fine, I buy your buyer A. But instead of the negotiation between just two parties trying to digress, it's between public markets and public information. So it's easier to negotiate and settle. So that's kind of like how we can understand markets. And basically, that's why we decided to jump into the real world asset tokenization phase. There's two types of tokenization that it's super important to understand. There's the external tokenization in the sense that the real world asset per se is not the asset tokenized, right? Because for example, there's a lot also in the marketing schemes that say like real estate is getting tokenized. In reality, the real estate, the hard asset, is not the one tokenized for various legal reasons that make it inefficient. So if we're talking about technology, pinpointing where is the efficiency optimization points, we don't have to change the rule of law what makes efficiency happens. And real estate and other terms are still not there. So the asset is not the thing that gets fragmented. The things that gets fragmented and optimized is the financial instrument linked to the real world asset. If we think of it, actually everything works like that, except natural personals name the asset directly. So I'm Edwin, I own a house. Perfect. But the company usually is the one owner of the assets. So that's where the investors come in. Investors come into companies exposing the financial instrument where a yielding or a revenue might happen for the retail. So, in that sense, I am a real estate company who wants to capitalize in order to exploit or fund myself to create a new hotel, so to speak. Then I can do a capital increase and I sell shares. That's of shares is a financial instrument that I can shoot into the market and then I can obtain funding for the real estate. But I'm not tokenizing the hotel. I'm tokenizing again a financial instrument into the company. Same mechanism can be for the debt. I'm a real estate company who wants to create a loan so I can get investors buying part of the loan and I'm giving them a percentage of top, it can be a fixed, a short term. So I'm giving them APY, so there's revenue on them. So loan, the financial instrument by which the company gets linked to the real estate. But again, it's not the real estate pure, the one getting tokenized. And obviously we can go about that treasury bills, the bonds, profit sharing scheme, convertible notes. But this is how crucial it is. So when we start talking about tokenization, yes, a couple of years ago, the marketing was mere at the asset level, kind of like, oh, you tokenize real estate, but you don't really. But it's easier as a marketing scheme for people to understand that the hard asset is going. But when you start getting to the specialization phase, financial instruments is the one getting tokenized. And thus, this is the reason why we're seeing a lot of examples of why Chainlink is working with banks, is working with asset managers, because the financial instruments is the one getting tokenized. That's why money got tokenized, because it's the one giving you access to all of this. So it's super important for us educators, so the ones working in the space, for people to understand that the mechanism for tokenizing real world asset comes at the financial instrument superseding the access to the real world assets. And if that is external company to the third parties, then we can go to the second scheme, which is internal. Companies can also start tokenizing, and we're starting to see a new trend with companies offering tokenized value to the employees or freelancers or access. So phantom shares, we're calling this restricted units in the sense that it's a company providing value to employees, such as vesting contracts. I give you shares in X amount of value, but I do it in the tokenized version to be more transparent. And you can add value on the, okay, if you're 3 years into the company, then it gets an unlock of the shares. So it's a pure mechanism that we're starting to see just because it's transparent, it's accessible, it's optimizable, and you can start playing with that. But Just wanted to throw as an example for us to understand that external tokenization happens. So company to third parties being investor, but we're seeing a trend that internal tokenization is happening. So company to whoever they want to tokenize, who is providing value as a whole to the company, right? So as internal, external, quite simple here. So, being a Chainlink Bootcamp, why did we decided obviously to join the program? And it's been quite the journey because of the technology. And one of the things that we builders have to understand is you got the chain layer, you may have the infra, the protocol, but the application layer it's crucial. We've seen a lot of trends, kind of like or explanations saying, what about the user experience, right? And this is crucial because when you are out of the tech initiatives of the blockchain and you talk to people who might not even be really good at technology or even turning on a computer, because I've seen it all, you cannot talk in the same terms because the same reasoning that we have here saying, oh, what is the most TPS chain or what is the most with the transaction value per day and all of the things that might worry us for us in the chain world, the developing thing, it might not be the same situation or problems that they're trying to solve in a, let's say, web 2. So one of the biggest hassles that we had back in 2020, there were some initiatives, but it was still very much in the building phase. Multiple chains, fragmentation. Gotta come here super clean and say I'm super against the diversification of chains and all the really great things that are happening L1s, L2s, L3s, subnets, and all of that because that fragmentation is not needed. I think optimization of some chains are good, and I think 2, 3 are gonna make it. But in the end, it's all about if it's hard for us to bring assets to a chain, imagine us bringing multiple assets to multiple chains. Options, if I was to throw to a client the following slide and I give them 10 options to get into a chain, they will stop talking to me because they will just have one problem, one solution. So the abstraction of the chain, it's crucial. So I was in Paris when they announced the CCIP, and I got super excited. I was like, if it works like they say it's gonna work, it's a game changer because I can abstract as the application layer the chain. And it's super crucial. I can have my favorite chain. I can choose Ethereum for security. I can choose Base for the gasless. Here's example because USDC is gasless, so it's super efficient for my clients to operate in a gasless experience, so they don't have to pay that much on each transaction that they will perform. So the important thing is if I am abstract and I provide the same level of opportunities, then I can create a great product. A client, again, real estate as an example, they issue the asset, the tokenized asset on Base without even knowing Base. I'm throwing them the Base layer just because USDC it's regulated in Europe or whatever the format, or because I just want to. And in the back, it doesn't matter where the investors come because I'm going to tell you a problem that we started seeing here because I am in Web3, but my clients and their investors come from a Web2 environment. And it's like I go to, for example, two biggest examples, Binance and Coinbase. If I go to Binance and buy USDC, they will drop me first on BNB chain because they have the connection. If I go to Coinbase as a client retail and I buy USDC, they will throw me back into Base as a fair option. Why do they do that? Because obviously association of chains and whatever. But the retail investor or the newcomer might not even know what's a chain, right? For them is I buy USDC because I have to invest in USDC. So USDC for them is USDC is USDC. Because if we were to think in the real world how it will, we would be saying like your euro is different from the euro that you received in Colombia. Why not? Right? It wouldn't make sense. Or the dollar that you got in China is different of the dollar that got in United States. And that makes absolute no sense because for them it's kind of like a dollar issue officially, it's a dollar issue officially, regardless of the where I receive it. So if we were to put that perspective into Web3, for them they get lost. And we had a lot of drop downs just because people would be like, wait, but I'm trying to pay with USDC. And then we will have to come from support and say, like, yeah, but you're in the wrong chain. And then it's kind of like a mind break for them. It's kind of like, what are you saying? I don't understand. You push me to go and buy USDC, and my first and greatest enabler is still an exchange, and then I come to your platform to invest in this global asset thrown by a client, and I cannot even enter because you're telling me I bought the wrong USDC. So imagine the pains that are for the application layer to start onboarding millions of users when we have so many options. Thus, CCIP. I'm giving you all the problem because this is a great solution. Us as builder, we have to always find one great problem to find a better solution, right? What happens with the abstraction of layers? The issuer gets the asset on the base layer, and then whoever their investors come through CCIP, it always ends up in the base, and the deployment back can always happen in the layer of their choosing. Obviously, for us, it's still a work in progress. We still have a couple of sprints before we actually deploy the full magnitude of CCIP. But so far, our experiments are performing exceptionally well because the only thing that we're pursuing on this end in Bricken as a tokenization platform is the absolute abstraction of the chain, because I think a lot of options are what can make my clients lose, and I just want them to sign in, deploy, get, and good to go. All right. So, uh, big fan of CCIP. Then, if we're gonna go more into the depth of real world asset, there's another thing that we should be discussing, and it's the proof of reserves. Proofs of reserve became a big thing back in 2021 with the FTC law fall, and many of the exchanges trying to prove that they had enough assets on their balance to be able to be traded. And proof of reserves came to be. We're abstracting that technology to be able to place it into the real world asset issuance. And how does it work? It's still it's not so, it's quite simple, but I'm going to add the complexity of what it means, but it's the same complexity that happens in real world actually. So if you have a, the proof of reserve allows us to stop the function of mint, right? So if you say something is worth 1 million, you cannot over mint 1 million. So there's a connection between real world asset value and on-chain value. All of this, it's the foundation of trust, right? Because people would like to enter into an asset that real value, it's connected completely. So there is the function of proof of reserves. At least that's how we're starting to use proof of reserves in Bricken, because we foresee that the trust foundation is key. So, for example, in real estate, again, we don't just do real estate. I'm just saying for the marketing, for the sake of the explanation, and not to fall trap into different kind of. But this is applicable to anything. That's what I wanted to say actually. So, the value that an appraisal of a real estate comes, this is, think about, forget about the chain. Let's talk about how real estate works. You want to buy a house, you go and ask for appraisal, right? Because if I tell you that my house is 1 million euros, you will be like, thank you very much, but who are you except that you are the pure seller? Do I trust you? I can say yes, I trust you, but I rather have a third party value the asset, because that's how a lot of things happen. A lot of auditors, if not auditors, wouldn't even have a job. Economic auditors, financial auditors, financial accounts auditors. There's so many auditors just trying to prove that value does exist and correspond to the asset itself. In the case of real estate, it's an appraisal. So you will bring an appraisal to get to the real estate, and based on that, the appraisal will say the house is worth 920. So maybe a negotiation will happen, but at least I know what is the real value according to the city, the meter square, the street, the condition of the house, the model, a lot of different variables. So that happens in real world. But now in the on-chain value, we can say like, oh, look at these people saying that they want a loan for a hotel that they have valued themselves in 10 million. Now, a lot of people will be asking, "Mm, but how do you get to that valuation?" So appraisals are still needed. One thing is that they're not provided by certain players, which could happen. In Web2 offline, it can happen, and in Web3, it can happen. But the radical importance is that the good players building the strong trust foundation, they should like knack something as a proof of reserve mechanism to showcase that the value they're bringing on chain corresponds to the offline value. So an appraisal gets digitized, It's a function level that establishes that if 920 is what the person said, 920 is the total value of the mint that you can create, because that's the max offering you can offer, because that's the max value of the asset itself. So the complication relies, which is the same offline, that if you are, I don't know, 5 years long into the last mechanism of value creation on chain, you will need a new appraisal, because values tend to change. So, for example, if we're here in Barcelona, for example, and 10 years ago, maybe you could buy a house for 200K in 70 meters square downtown. 10 years later, that's almost impossible. It has double or triple the value. So you will get a new appraisal. That will mean you have to reignite your function level, because your value just got through. But it can happen the other way as well. Kind of like, hey, there's a big burn in the building, or I don't know, it got unsafe the area, so the appraisal goes down. So it's important that we don't lock the value on one snapshot. We continuously provide snapshots along the way to be able to have a correct value offline. Now, this is the complications of real world assets, which is kind of like how you balance the offline value to the online, because offline, mm, there's no such transparency. So actually, there's not such movement. So that's why markets are illiquid. It tends to be very peer to peer, kind of like one person selling to exactly the person of their choosing. But when you go on chain and you start opening markets, it's important that all these transactions and the true value gets locked and it's optimized throughout time. So it may require for you to get most by various appraisals or various measurements of value, because you always want to pinpoint what is the connection between the offline value and the online value, because some things may happen in the future which right now are not there yet because the markets are still getting. But if we see arbitrage happening in online assets, I can tell you that maybe in the near future, when markets become more liquid, at least in the real world asset, there's going to be a lot of arbitrage opportunities. So that's kind of like something that, through obviously oracles, price feeds, proof of reserves, and all this, we want to evade, because arbitrage is good for the trader, but it's never good for the asset itself. So those are the kind of like the two functions we are very much excited. Obviously, we just a lot of different price feeds. Oracles being the Chainlink top of the house, best out there without doubt. But I'm gonna really establish that if I can provide a really good what do you say, advice, study CCIP. I think there's a lot of making here, and I think the abstraction of the chain, it's actually what is gonna bring millions of block value, just because people like one option, one solution, and one click. So that for us is how we doing everything. So um, the new just wanted to end up saying that tokenization is definitely creating new frameworks. As we said, external value being tokenized with internal value. So a company looking for funding or capital through third parties, then going back internally to employees. There's a lot of new interconnectivity between kind of like third parties internally, which is happening. And the most important thing is that transparency can bring trust. So you can provide trust to your investors, you can provide trust to your employees, you can provide trust to whoever wants to go, because you just become transparent in the process. So that's becoming more compliant. There's a lot of things that legality wise, even though it might seem that it's one or the other, blockchain or legal. Actually, if we were to really fully understand the power of blockchain and the public ledgers and how everything moves, compliance can definitely become simpler. So it's all about like that process. I've been here building for 4 years with Bricken. I have no doubt we are better than yesterday. We still have a long term to go, but I can definitely tell you that the space that we are currently in 2024, I have never witnessed such growth and such, let me say, even the word FOMO, from bigger money institutionals jumping in because they find this new technology super efficient, a lot of optimizations happening, a lot of trustworthiness. So yeah, I wish you all the best on your journey. And on my side, it's been an absolute pleasure talking to you. You have any questions? There's my email. Yeah, you can find me on Twitter, EDWMATA, or you can find me on LinkedIn. And it's been a pleasure. Thank you very much.
Thank you, Edwin. This was amazing. Thank you so much for sharing your real-world experience with real-world assets. As being mentioned, if you have any questions for Edwin, you can drop them in the chat now, or there is his email and socials for the Bricken over here, so you can find him and connect afterwards. And this talk pretty much sums everything up. This is it for this bootcamp. As we briefly covered this page, there's like these next steps that you can follow along to stay in touch with us. So we mentioned SmartCon and Hacker House. You're definitely encouraged to join us there. You can always subscribe for Chainlink Developers newsletter to receive monthly updates about everything what's new inside the Chainlink ecosystem. There is also our Dev Hub on dev.chain.link with fresh new experience. So I encourage you to check that out. You can also get in touch with our developer experts. Obviously, whenever you want to build something with Chainlink, your first number one stop should always be the official documentation. So that's always up to date and available on docs.chain.link. And in general, if you want to learn more about Chainlink, there is the official main website, chain.link. So yeah, that was it. Thank you for joining us for these past 2 days. And yeah, keep working, keep studying. Deadline for homework is October 4th at midnight ET. If you have any follow-up questions, there is our Discord. And if you have any follow-up questions for Edwin, there was his email and other contacts in the Gitbook. Thank you and see you soon.